Alright, so we're going to take a look at an example. This is a skiing example from the 2006 Olympics. Ted Ligety was the American who won the gold in the men's combined skiing event, where it's two events where you take your two times, you add them together, and the skier with the best, in this case the fastest, the lowest combined times wins the gold medal. Well, Ted Ligety had a downhill time of 87.3, or this is his slalom time, was 87.93 seconds. His downhill time was 101.42 seconds. Well, you might say to yourself, he's clearly a better slalom skier than downhill skier because his time was much better. However, in this case, you're comparing apples and oranges because the slalom event might just be a shorter event. Maybe skiers always, or nearly always, ski the slalom faster than the downhill. So what we need to do is we need to be able to compare his slalom time to the group's slalom time, which was 94.2714 seconds. That was the average slalom time. So Ligety was definitely below average in the slalom. And here he is in the downhill, where he is also, again, below average in the downhill. He's much closer to the average in the downhill. However, if you look closely, the standard deviation for the downhill, or the average deviation from the mean, is much smaller than the average deviation from the mean in the slalom. So in order to be able to compare his performances in these two events, we really need to look at standardized scores, or z-scores, for the two events. So let's determine how many standard deviations below the mean was Ligety in the slalom, how many standard deviations below the mean was he in the downhill, and in whichever one he was farther below the mean on, that would have been his better event. So to do that, we're going to take a look at our z-scores. So let's find our z-slalom for Ted Ligety, which we will find by taking his slalom time minus the average slalom time divided by the standard deviation for the slalom times. In this case, if we take his time, 87.93, minus, undo that, minus the average slalom time, big long number here, 94.2714 seconds, and we're going to divide that by the standard deviation for the slalom times, 5.2844. So I'm going to actually, I can't actually use the calculator on the screen there while I'm still writing on it, so I'm going to use my hand calculator here. Sorry for that one just sitting there doing nothing on the screen, but 87.93, subtract off the 94, and then we're going to divide that by 5.2844. It looks like we're looking at Ligety was about 1.2 standard deviations below the mean for his slalom time. Now let's do the same for the downhill. Z downhill equals, alright, in this case we're going to have Ligaty's downhill time minus the average downhill time divided by the standard deviation for the downhill times. So just grab the numbers, plug them in here again. You notice how I kind of took inventory. The problem is it's got an awful lot of words in it. So the first thing I did was I just read through it, and I made a list of all the things that were going on in the problem, all the things we knew, the data values, the statistics that were reported in the problem, and then we can go from here and do our calculations. It's easier for me to do that than to continually go back and keep rereading the problem. So now we're going to go ahead and find the z-score for his downhill times, just doing some number crunching here on the side. And it looks like while he was below average, he wasn't below average by much. He was only about 0.21 standard deviations below the mean in the downhill. Now some of you might be saying, hey, I actually kind of knew that before we even started doing the calculations on our calculator. You can see in the downhill times, if you look at his downhill times, that his downhill time is only about 0.4 of a second below the average downhill time, but the standard deviation is way more than 0.4. So clearly he wasn't an entire standard deviation below the mean in downhill. However, over here, what's the difference there? Well, it's clearly more than 5. I'd have to go ahead and subtract that off in my head. 4, 5, 6. It's probably closer to 6 and change seconds that he was below the mean. 87 is more than 6 seconds below 94, which is more than 1 standard deviation. So he was less than 1 standard deviation here. He's more than 1 standard deviation from the below the mean here. So his better event was the one where he was the fastest, and he was 1.2 standard deviations faster than average in slalom. So Ligety, it appears his better event was the slalom, where he was a good bit below average. Being closer to average in downhill didn't hurt him that much because he was able to win the gold in the end. So hopefully this helps. You see how you can use z-scores to compare two different types of statistics or values.